Hello everyone, welcome to this video lesson. In this video lesson, we are going to talk about polarization of the light. Polarization is the phenomena of restricting the vibration of the light to only one plane. Restricting the vibration of the light to only one plane is called something like polarization. To explain the polarization, we need to depend on Maxwell's electromagnetic wave theory, which says that light is an electromagnetic wave. When at the source level some disturbance is created, which creates a variable electric field, and that variable electric field will create a perpendicular magnetic variable field, and the direction of the light is perpendicular to both of them. That's how electromagnetic wave works, where the velocity of the light in that medium is root of, if it is vacuum, mu naught epsilon naught, and so light has both electric and magnetic field vibrations, but magnetic field vibrations B are not responsible for any of the optical properties. Nothing to do. So, what all we get due to the optical properties like interference, diffraction, and polarization can be explained basing on the variation of the electric field in the electromagnetic wave with time. So, how does E varies with respect to the time is it has vibrations in both x directions as well as y directions. Electric field vibrations along the x-axis are shown with double-edged arrows. Electric field vibrations in the y direction are shown with double-edged arrows into the board, so they appear like dot. So if you want to represent an unpolarized wave, that's a normal light, unpolarized light. It has electric field vibrations. It also has magnetic field vibrations. Arrows represents electric field vibrations. Dots are the arrows into the board, which also represents the perpendicular electric field vibrations. And the direction of wave motion is perpendicular to both of them. That's how electromagnetic wave looks like. So, the whole electric field E can be resolved into components as component of the electric field along x direction and the component of the electric field along the y direction. Being this is radially outward, it is 45 degree. So this becomes E naught by root 2 if this is E naught, and this also becomes E naught by root 2. So continuing this discussion further, a polarized light will have vibrations in both the planes, in both the directions, x and y. A unpolarized light will have vibrations in both the directions, whereas a polarized light, being vibrations are restricted to one plane, will have vibrations only in one plane. Then, how is this amplitude and intensity are distributed is the point that we would like to discuss. So this is the light with an amplitude A or A naught, which is radially outward. So this angle is 45 degree. So this is the amplitude along x-axis, this amplitude along y-axis. So Ax will be A naught cos 45, whereas Ay will be A naught sin 45. So both of them are having amplitudes of A naught by root 2 and A naught by root 2. So they are not divided as A naught by 2 and A naught by 2 along x and y direction. Rather, they are distributed as A naught by root 2 and A naught by root 2. We know that the intensity is directly proportional to square of the amplitude. So if you want to write how much is the intensity there, if you draw the same graph, say this is the intensity I, if this is Ix, say I naught, and if this is Iy, Ix is just equal to Ax square. Ax is nothing but equal to A naught by root 2 whole square, that is A naught square by 2. A naught square is nothing but I naught. So the amplitude is going to be equal to I naught by 2. So the amplitude is distributed as A naught by root 2 and A naught by root 2, and the intensity is distributed as I naught by 2 and I naught by 2 on both x and y axis. So if you now restrict the vibrations of the light only in one plane, the unpolarized light has an amplitude of A naught, has an intensity of I naught. The phenomena of restricting the vibration of light to one plane is called polarization. So once if you polarize the light, the polarized light has an amplitude of only any one of them, A naught by root 2, and having intensity of only any one of them, I naught by 2. So the polarized light is having only intensity of 50% of unpolarized light. That makes a sense. Why do people wear polarized sunglasses in the summer day? Because it gives you only 50% of the original sun intensity, so that we feel much better. We'll discuss further in the coming video lesson. Thank you for watching.